looking at the equation of a circle a little bit more. The equation of a circle, if you remember, x minus h squared plus y minus k squared equals the radius squared. This definitely doesn't look like that. First thing I want to do today, and the rest of the day will be way easier, but I want to look at this and show how we can make it look like that. In order to do this, we have to remember completing the square. And if you need to go seek elsewhere to remember completing the square, I'm sure there's other videos here on my channel to do that. But this isn't a remember how to do completing the square video, it's how do we apply completing the square to change this to look like our typical form for equation of a circle. Because if we can do that, then we can find the center of our circle, we can find the radius of our circle, and so on. Well, the first thing we need to do is we need to group the x's together. And group the y's together. And I'm just going to, well, I'll just leave this 51 right here. Other people might say move that 51. I'm not going to worry about that right now. Now, if you remember, in order to complete the square, we have to have a 1 as the coefficient to our variable being squared. And we are doing 2 completing the squares. This might be the first time you've ever seen that happen at once. But we're just look at this for a second. We need to get that 4 to the outside. I'm going to leave some space in my parentheses. And then I'll go ahead and set this one up too. I've got to bring a 4 out. 4, so I've got y squared minus 6y. I'm going to leave some space in my parentheses, plus 51, and all of this equals 0. Now, to complete the square, we take the coefficient in front of our x, we cut it in half, we square it next, we paste it onto the inside here. So 4, cut it in half, we get 2 squared is 4. Doesn't matter what the sign is when we square it, it's going to be positive. We multiply it times the number out in front, and we subtract that. 4 times 4 is 16, so I'm going to be subtracting 16 from the outside. Because essentially I just added a 4 to my problem, because 4 times 4 is, I just added a 16, 4 times 4 is 16, so I need to subtract a 16. We do that same thing here. Take the coefficient in front of my x, take the coefficient for my y, cut it in half, square it next, that gives me a 9. Multiply it times 4 means I need to subtract 36 from the outside. Okay? Now, there's a 4 out in front here. This is x minus 2 squared. There's a 4 out in front, but this is y minus 3 squared. 51 minus 16 minus 36. I don't feel like doing that in my head. That gives me a -1. Everything equals 0. Well, we need to continue making this look like that. We need something over here. I'm going to add the 1. So we have x minus 2 squared, 4 times y minus 3 squared equals 1. And notice we do not have a coefficient in front of here other than 1. So these 4's really shouldn't be here. I'm going to divide both sides by 4, which gives me x minus 2 squared plus y minus 3 squared equals a 4th. The center is 2, 3. The radius would be a half, because a half squared gives us a 4th. That's how we can use completing the square to find the equation of our circle. Now for some easy stuff. All right? If you remember the equation of our circle, we just changed that bad guy into that form right there. We're going to look at moving the graph of our circle. Here we're going to translate And when we translate, all we really have to worry about is moving the center, and everything else just works. Here it says the equation of our circle is that. Translate this circle 4 units to the left and 2 units down. Write the equation of the translated circle and sketch both circles on the coordinate plane. We'll worry about the center. The center is 3, -2. 4 units to the left means I need to subtract 4 units from my x. 2 units down means I need to subtract 2 units from the y to give us a new center point of -1, -4. 4 units to the left, 2 units down. So our new equation of our circle is x plus 1 squared plus y plus 4 squared. The radius was unaffected though. We can plot this. No big deal. -1, -4. The radius is 5 because equals r squared. I could get some more points, but I know you're already bored of me today. And so we've got our circle there. The original one had that center at 3, -2, but we shifted it over to the left 4 units, down 2 units to get to where we are now. Yep. Here it says the equation of our circle is given. Apply dilation centered at the origin with a scale factor of 2. Write the new equation and sketch both circles on the coordinate plane. Well, our dilation was a scale factor of 2. Okay, so the origin is the center of our circle. Notice that. So that's really helpful to us. The center is not going to change because the dilation, the center of the dilation and the center of our circle are the same in this case. But what really changes is our radius. Our radius was 7, but we double that because our distance out is going to, of course, double. So that means we have y squared plus, or x squared plus y squared equals 14 squared. We have to double our radius, and 14 squared is 196. So x squared plus y squared equals 196. So our radius is 14, 9, 10, 11, 14. It's going to be way out there, 9, 10, 11, 14. I mean, our circle is huge, whereas the original one had the same center and was also pretty big, but it also fit in our coordinate plane pretty easily. So it says doubled the size. Here, the equation of the circle is given. Apply a dilation centered at the origin with a scale factor of 1/3. Okay, they're both still centered at the origin, which is nice. The center did not change. Ooh, sorry. The center of dilation is at the origin, but the equation of our circle shows that the center point is 9, -6. So there's the center of dilation. Let's look at our circle, our original circle, which is at 9, -6, which is over here. The radius is 3. So it looks something like this. We know that since the center of dilation is right here, it's going to get closer because the scale factor is 1/3. As it gets smaller, it's also going to get closer to that center of our dilation. Okay, so what can we do to perform that dilation? We can multiply 1/3 times the center and the radius. So that means our new center point is going to be 3, -2, and the radius, which was 3, is now 1, which gives us the equation of our circle, which would be x minus 3 squared plus y plus 2 squared equals 1. When we graph this, our new center point at 3, -2 with a radius of 1. It does look a third of the size. It also looks a third of the way to the center point, 2/3 of the way to get to the old center point. Yeah. Finally, here it says a coordinate plane is overlaid on the map of a city to help place a tornado warning siren. The current location of the siren is shown on the coordinate plane, where each unit represents 1 mile. At its current volume, it is audible to everyone in a 2-mile radius. Suggest a translation and an approximate adjustment to the siren's volume that would make the siren audible to everyone in the city. Well, if we look at this, we want to center this so that our circle overlaps as many people in the city as possible. Okay, so we need to find the center of this. Currently, it looks like it is at -2, 3. Okay, the current center at -2, 3, and the radius, which I don't think we're going to be able to change the radius. We can't just say buy a better siren, but the radius is 2. I think it's going to stay at 2. We want to move this to where it's as centered as possible. So if we kind of get an idea here, this is from 3 to 2. The center would be right here at -0.5. From -1 to 4, the center would be at 1.5. Here would be the center of the city right there. I found the midpoint of each side of our rectangle, essentially. And so the center, would be really nice to move the center to where our center is now at -1/2. One and a half, which would give us an equation of our circle of x plus 0.5 squared plus y minus 1.5 squared equals 4. That's the new equation of our circle. And what do we have to do to get there? We need to go right, to go from -2 to -0.5, we need to go right 1.5 units, or is this in miles? I guess this is in miles, right 1.5 miles, and we need to go down 1.5 miles. I don't know if this is in north, south, east, west, so it could be go east 1.5 miles, go south 1.5 miles. But on our coordinate plane, it looks like right and down.